Constructing antiderivatives. Essential question. Can I construct an antiderivative given the derivative graph? Let's take a look at this graph. This graph represents f of t, and we'd like to find the antiderivative, which means we are going to take a look at an area accumulation function. This is an input-output function as we've studied in the past. The output will be how far will we go when we're collecting the area, and the output will be the area itself. All right, let's go ahead and find our first point. We're going to go from 0 to 0 of f of t dt. Now t is acting as the dummy variable, and this is actually the function that we're given right here, and this represents the heights and the widths of all the rectangles from 0 to 0, and the answer will be 0. Now we're going to find the area accumulator from 0 to 1 of f of t dt, which means I want to find all of this area right here from 0 to 1. And I don't really need to go through a summation of rectangles because this is a geometric area. I know that the area will be equal to -1. How do I know it's negative? Well, the heights are negative, the widths are positive, so this is -1. Now I'm going to go from 0 to 2 of f of t dt, which means I'm going to go from 0 to 2, and the answer will be -2. Area from 0 to 3 of f of t dt, which means I'm going to go from 0 to 3, and that'll be -3. 0 to 4 f of t dt, and I'm going to accumulate just a little bit more area to make this -3.5. Okay, now I want to go from 0 to 5 of f of t dt. Now's the point at which I am going to be adding area between the curve and the x-axis that's above the x-axis. Well, remember this is dead area, so this area right here will cancel with this area, which means I will now have -3. And then I'll continue to add more positive area to that result, and I'll have -1.5, 0, and then 0.5. Let's go ahead and graph this. 0, 0, 1, -1, 2, -2, 3, -3, 4, -3.5, 5, -3, 6, -1.5, 7, 0, and 8.5. All right, what we want to be able to see is those characteristics we've seen before. Right here, we know at this point, this is a critical point where the derivative is equal to 0, and we can see it goes from negative to positive, so we're expecting to see, and we see it, we see a minimum value. So where does g have a minimum value? It has it at the point 5 or 4, -3.5. Okay, let's try another problem. You can see the graph, the derivative has not changed, but the area accumulator has changed just slightly. Instead of starting at 0, we're going to start at 2. So that's why I'm going to start accumulating my area as well here. From 2 to 2 of f of t dt is going to be 0. I'm not going to collect any area. From 2 to 3 of f of t dt means I'm starting here at 2, going to 3, so I'm collecting all of this area, and that'll be equal to -1. And I'll go ahead and just write the other points here. On the next screen, you'll see the rest of it. What I'd like to address right now is finding the area from 2 to 1 of f of t dt, which means I'm going to go from 2, and I'm going to go backwards and collect this area. Now, that answer will be +1. Why? Well, I'm going to the left, which means my x's are going, my little widths of x's are going to be negative. and my heights are already negative. Now, if this bothers you, I can handle it a different way. I can go ahead and go from, instead of a big number to a small number, small to big. Now, once I change the limits of integration, then I have to take the opposite sign here. Now, to go from 1 to 2 is going to give me a negative 1 as my answer for this integral, but it's preceded by a minus sign, so the answer is going to be 1. So this will be 1. And as I continue toward the left, you can see I'm going to have a 2. On the next screen are all the answers and the curve. Notice that we still have this characteristic of the min being at 4. Okay, the actual min value is different because the curve has shifted. Okay, your turn to try. I want you to notice the new area accumulator starting at 3. So make those adjustments. Stop the screencast and continue when you're ready. And here's the answer. And again, right here at 4 is our minimum value. And again, this curve is shifted.